Hi, in this video we're going to be changing a function from standard form of a quadratic to vertex form of a quadratic. All right, so the first thing that you always want to do is you want to look at that coefficient here. So we have a negative x squared, which means we cannot see it, but there is a negative 1 here. All right, so the first thing we want to do is factor out that coefficient. So we're going to factor out that negative 1, and so we get y equals negative 1. And now we're dividing everything by negative 1. So that's negative x squared becomes positive x squared. And that 2x, negative 2x becomes positive 2x because we divided by negative 1. And this becomes positive 9 or plus 9. Okay, so now we're going to be focusing on those two first terms. And if you haven't learned how to complete the square yet, I would suggest you watch that video before finishing this video and then returning to this video. So if you've learned how to complete the square, you know that when you focus on those two terms, what you want to do in order to complete the square, and when I say complete the square, I mean make an expression that's a perfect square trinomial. What you want to do is you want to add b over 2 squared to both sides. But that's what you learned before. That's actually not quite what happens here. But we are going to be adding b over 2 squared. And then we're going to have to do something with that. So I'm going to take this 9 and I'm going to just move it over a little bit. I'm not getting rid of it. I'm just moving it over because I need space to do something with that 9. Move this parentheses a little bit as well. All right, so with that said, our b value is right here. So b over 2 squared is 2 over 2 squared, which is 1 squared, which is just 1. All right, so now I can complete the square by adding that. And so now what you learned before when you were solving quadratics was whatever you do to one side, you have to do to the other side. So we typically, in the topic before, would be adding 1 to this side and taking it away from that side. But that makes no sense here in this specific type of problem. What we are trying to do in this problem, we don't want to change that value. We can't just add 1 and then just live in a world where we just added 1. So we have to now take it from that side. So by adding 1 and then taking away 1, you didn't change the value of that expression at all. But we need to do that so we can get a perfect square right here. So now that is a perfect square. And so now we can go ahead and factor that. So in order to factor that, we're looking for two numbers that multiply to 1 and add to 2. And so those two numbers that multiply to 1 and add to 2 is just 1. So now we can continue. We have our negative 1 here, and we factor x plus 1, x plus 1. So let me highlight to make sure you understand what is what. All right, so in pink, that's that negative 1. We just carried that down. What we factored just now in gray, so this piece is just this here, factored. And here we have plus 9 minus 1, so that is plus 8. And so here in blue, we don't have blue there. So here in purple, this here is just this here. All right, so now we're almost done. All right, so here we have y equals negative 1, x plus 1 squared plus 8. All right, so now when we distribute that negative sign, we get negative 1, x plus 1 squared minus 8. So the sign here for that 8 changes because of the negative 1 that's in front. All right, so now that we have that, if that looks like vertex form to you, wonderful, because it is. And if you need a quick review of vertex form, let's make sure that you see what that looks like. So when we have a function and it's in the form y equals x minus h squared plus k, the vertex is h comma k. and pay attention to the signs here. So here we have our H, but notice since that's a positive sign, or x coordinate of our vertex is -1, and the y coordinate of the vertex is 8, following that format here. All right, and so that's our vertex, and we are all set.